Welcome to the Pharma Toppers friend. Today our topic is the milling. First of all, milling. What is the milling? It is the simply is the mechanical process to reduce the particle size of the solid. It includes the terms like grinding, pulverization, crushing, dispersion, etc. And all of them is generally a reduction of particle size. The size of solid particles are conventionally expressed in terms of mass size. What is the mass size? If I consider one square of 1 by 1 inch on both side, the square. Okay, if I'm having 10 holes on this side, 10 holes on this side, means total 10 square is the 100 holes in 1 inch. Okay, then that the sieve made up of that type of sieve material is termed as the 10 mass sieve. And according to that which type of particles are there, they are classified on the basis of coarse milling, which produces the particles larger than 20 mass, intermediate milling process in which the particles are of 20 to 200 mass, and the fine milling produces the particle greater than 200 mass. Here I want to tell you that as the mass size increases, the number of holes per unit area, that is 1 inch square, decreases. So particles become more and more smaller. So why milling is required? First of all, in case of the pharmaceutical industry, dissolution is the process by means of which drug material is available in GIT for the absorption, and this can be checked in vitro. So here, as you all know, particle size reduction lead to higher surface area, and higher surface area will provide better dissolution and time for extraction. In case of the natural products, that material which is having the smaller size, which will be having the higher contact area, and due to that contact higher the contact area, there will be the better extraction. And when I come to the drug delivery perspective, that aerosols, as you know that our respiratory tract, it is like a tree. So from starting from the upper part to bronchi to bronchioles to alveoli, the continuously size is reduced. So if I want to target my bronchi, then different particle size is required than that of for alveoli. So if I go for the higher bigger particle size, then it will target the upper part of respiratory tract, and as the particle size reduces, it is able to penetrate further deep in the respiratory tract. So that is the basis of the aerosol systems and the distillation of crystal. In case of crystallography, that as we all know that the crystal is the most stable form. Okay, when I convert the crystal to the amorphous form, it will give the obvious solubility advantage. So to get that obvious solubility advantage, we go for distillation of crystal, and for that also milling is required. So this is all about why milling is required. Now these are the some mills which are used for the size reduction, including hammer mill, roller iteration mill, fluid energy mill, cutter mill, and the colloid mill. Another one is the ball mill, and here I want to tell you that cutter mill. Cutter mill is simply the chopper. It chops the material in two parts. That's all. And other mills I'm going to discuss in detail. So first of all, hammer mill. It is generally used for the material which is going to use for the wet granulation. The materials is feed at on the top and then thrown out centrifugally and sieve materials. As you can see here in figure, that is the feed, and then it is the these are the hammers attached to the central shaft, and materials comes here, then they are centrifugally rotated, and here is the sieve is there. On the basis of the size of the sieve, which type of material we require, it will pass through this sieve and collected in this discharge part. So this is the process of hammer mill, and generally, as you can see here, it is used for almost all drugs. So next mill, whether ball mill. Okay, here ball mill is the, generally you can think that the one cylinder, which is one big cylinder which is filled with lots of small balls. The small balls can be vary in size, and as you can see here that smaller balls gives the fine grinding. Okay, and ball mill uses the impact and iteration. Impact by, if one surface is there and you throw your material on that surface, that is termed as impact. And while attrition is the rubbing of one material to another material, and this will lead to size reduction. Here, critical speed is one of the parameter which governs the efficiency of the ball mill. Okay, so in this case, critical speed is given by this equation, and at critical speed or above the critical speed, there is no significant size reduction occurs. So here it depends on the weight of balls and its angular velocity. You can see here that as critical speed increases, the orientation of balls, if the 0% critical speed is there, there will be very small amount of mixing, and then a size reduction is there. And as the ball speed increases, you can see here it will start cascading movement. And here you can see that 50 to 70% of the critical speed, it is a good speed which shows impact plus attrition with the cascading movement. And as the critical speed 100%, you can see here the balls are centrifugally oriented and there will be no cascading movement. So it won't allow the proper mixing and further size reduction. So here generally the ball mills are operated at the 60 to 80%, 85% of the critical speed for efficient mixing. And followed by the size reduction. Now next is the fluid energy mill. This is also the same one. It uses both impact and attrition. And here the particle size attained is much smaller than that of previously mentioned those two mills. Okay. So here they uses the air jet. Air jet is kind of, here you can see in this figure that this one is the air jet. Here the inlet pipes are there, and then your material is fitted here. Then this air jet drives that material to the upward part, and by means of impact of that material to the walls of the mill and interparticular attrition lead to the size reduction. And this is the exit, the required material of required size which exit from here. So it's all about the fluid energy mill, and it can produce a particle size of the 2 to 20 micron. And one disadvantage related with this mill, it shows the very high amount of fines, but it can be overcome by adjusting the jet speed. Next is the colloid mill. Generally this one is used for the production of emulsion and not for the dry particles. It is based on the rotor and the stator principle, in which one stator is there above which one rotor is there, and continuously it will move from one side to another side at on the speed of 2000 to 20,000 rpm, and the space between rotor and stator is adjusted to get the desired size globules of the emulsions. Thank you, and that is all about the milling. And for more videos, please subscribe to the Pharma Top.